Hello everyone, my name is Todd Bellucci and I'm going to be talking to you about cooling towers and energy production. The outline of my PowerPoint presentation is going to follow the format of the issue paper. It's going to consist of the issue statement, introduction, background, analysis, discussion, conclusion, and then a list of references at the end. And if you look on the right, you can see an image of just how a basic cooling tower works with the hot water going into the cooling tower. It gets condensed and then recirculated through the cooling system in whatever power plant's associated with. So the main issue statement I focused on for this issue paper is the current use of cooling towers in energy production is challenged by a large demand on freshwater usage, coupled with high construction and operating costs that decrease its viability as a primary cooling mechanism in lieu of once-through cooling alternatives. And when I say freshwater usage, I'm talking about using the water and consuming the water. So introduction, background. As the population increases, the demand for electricity also increases, and that puts a strain on the electric generating industry to ensure there is adequate power supply to meet the growing demand. It's currently estimated that the demand for electricity in the US will grow by 33% from 2008 to 2035 and will likely increase by 49% globally. Unfortunately, most power generation comes bearing the cost of producing waste heat that needs to be discharged in the environment via nearby water bodies or the atmosphere. In the United States, approximately 89% of the energy is produced by thermoelectric power plants, while the remaining 11% is primarily made up of hydroelectric, wind, and solar. Historically, most nuclear and fossil fueled power plants would utilize surrounding water bodies as a source of cooling water and ultimate heat sink to support their production. And this usually involves an intake and discharge structure designed for once-through cooling that results in the waste heat being discharged to the surrounding water body, thereby creating thermal pollution. Cooling towers are an alternative to once-through cooling mechanisms in that they discharge heat to the atmosphere instead of utilizing natural water bodies. However, constructing and operating cooling towers comes at a large cost and needs a source of makeup water, which is commonly nearby fresh water or municipal water, domestic water, to support blowdowns and evaporative losses. Currently, about 43% of existing power sources in the United States utilize once-through cooling mechanisms in lieu of cooling towers. To put this in perspective, in 2005, the total freshwater withdrawal in the United States was 349 billion gallons per day, with thermoelectric power plants accounting for about 41% of that total. The purpose of the cooling tower is to eliminate the need of once-through cooling systems and significantly reduce the amount of thermal pollution discharged to the environment, as well as to eliminate the entrainment and impingement of aquatic organisms. In a wet cooling tower system, the hot condensate is cooled by the atmosphere via evaporation of plant water, and a packing of closely spaced bars called fill are used to allow hot water in the condenser to collect and either evaporate or cool the condensate. Wind through the tower created via natural draft also aids in the cooling of the water. And although a mist eliminator is normally placed over the cooling tower, it's inevitable that there will still be an atmospheric loss of water over time, requiring periodic makeup to the system with additional fresh water. And approximately 2% of freshwater withdrawals in the US come from wet cooling towers. And that number is significantly less than the 89% withdrawn from once-through cooling. However, that 2% that is withdrawn is going to be consumed instead of discharged back in the environment for the most part. Dry cooling towers are constructed to allow recirculated water to flow through thin tubes that are cooled by air. And although there is no loss of water from dry cooling towers, they are less expensive to maintain. They are more expensive to build and cause a loss of plant efficiency due to back pressure on the turbines. So it is important to note that water treatment is necessary for cooling towers to prevent corrosion of plant piping and structures from microbes, ions, particulates, polymers. and corrosion inhibitors such as molybdenum, ethanolamine, or hydrazine may be used to prevent certain types of corrosion. However, blowdown from cooling towers will contain some of these corrosion inhibitors, and it will likely be discharged to the environment under a NPDES, National Pollutant Discharge Elimination System permit. Once discharged, they will become pollutants in the environment, and unlike once through cooling, which does not need the same type of chemical control that closed systems would to maintain high pH levels and low oxygen levels in its environment to prevent accelerated corrosion. Some of the common types of corrosion include flow accelerated corrosion, microbiologically induced corrosion, and chemical attack. Figure 1 to the right depicts the normal operation of a cooling tower and different forms of corrosion that can cause structural damage to piping, and allowing for the additional release of water to the atmosphere. So, one thing I found interesting is during a study on the comparison between vertical cooling towers and once-through cooling from a river, conducted by Stewart et al. In 2013, it was identified that 28.4% of thermoelectric waste heat is directed to rivers, while about 25.9% is directed to cooling towers, and it was found that 100% of thermal pollution was eliminated from nearby riverine ecosystems from the use of cooling towers in lieu of once-through cooling. Additionally, the use of VFDs, which are variable frequency drive technology in cooling towers, was examined by a study by Al-Bassam et al., which compared the cooling tower water usage with and without VFDs. Specifically, a dual-speed cooling tower operating mode was compared against a VFD mode for a number of operating parameters, including water wastage, water temperature, and energy use, and figure 2 to the right depicts the results of this comparison. The operating costs of dual speed versus VFD technology in cooling towers was also examined and showed that the payback period for the initial cost of VFDs was 2 operating seasons due to the reduction in fan usage, and it was found that approximately 616,000 gallons were saved in a 3-month period by utilizing these VFDs in cooling towers. In another recently conducted study on international water consumption in the energy sector, it was determined that approximately 52 billion cubic meters of fresh water is consumed annually to support energy production. And consumed, not used, so that water isn't released back to the environment. Of the thermoelectric power plants utilizing fresh water, plants with cooling towers use significantly more water than those with cooling ponds or once-through cooling systems. Figure 3 on the right depicts water consumption factors on several different fuel sources, including coal, nuclear, gas, oil, biomass, waste heat, geothermal, solar, and wind. These fuel types were also broken down by their generation technology, including steam turbine, combined cycle, gas turbine, and photovoltaic. Lastly, the type of cooling technologies employed were assessed and included cooling towers, once-through cooling, air cooling, and cooling ponds. Results from the study above concluded that there was a significant increase in fresh water consumption from electric generating facilities utilizing cooling towers in lieu of once-through cooling or other alternative mechanisms for cooling. For example, in Figure 3 on the slide before, shows that the water consumption factor is about 3 times higher in a steam turbine plant utilizing cooling towers than those using once-through cooling. And interestingly, the cooling tower water consumption factor was not much higher than that of once-through cooling for combined cycle plants, but in most cases it was much higher for other types of plants. Although there is a decreased impact on nearby water bodies from not using them as a cooling source, there is an increase in the amount of freshwater consumption used to cool the towers. As seen in Figure 2 in the preceding slides, the percent of water wastage of cooling towers without VFD technology is over 48% and is still over 22% for towers utilizing VFDs. Although cooling towers help to eliminate the impact on aquatic organisms from thermal pollution, their consumptive use of fresh water provides a challenge to nearby ecosystems as well as availability for other domestic uses. It was found that the main threat from recirculating cooling water systems is during low flow seasons or drought, which can impact fish habitat and put other downstream water usages at risk. In conclusion, the usage of cooling towers is being mandated by state and federal governments for most new power plants, or in many cases, ones seeking permit renewals, such as NPDES permit renewals, in order to mitigate the impact on the environment and use the best available technology. Unfortunately, cooling towers, mainly wet versus dry, present their own impacts on the environment that is not associated with thermal pollution. Consumptive water use will present challenges to nearby water bodies, especially during drought and low flow seasons. Riverine and small lakes and ponds are more at risk than larger bodies of water from excessive water consumption. Utilizing municipal water sources as a makeup water source for cooling water is another option, but prevents that water from being used for drinking or domestic purposes. Although treated municipal water is another potential option as a cooling tower water source, it has not been studied enough to be a viable alternative and is currently not regulated or practiced in the industry. In addition to consumptive usage concerns, blowdown from chemically controlled water towers that are discharged to the environment will be a source of pollution to nearby water bodies. And additionally, although the large upfront costs associated with constructing and maintaining cooling towers is also a deterrent for power plant operators to utilize cooling tower technology in lieu of once-through cooling. And a comparison of environmental impact between thermal pollution from once-through cooling and consumptive water usage from cooling towers should be conducted on a case-by-case basis to determine which method will have the smallest impact on the environment. And below are the references. And I didn't include this in my presentation, but in many cases that I've seen in doing this research, having cooling towers with large amounts of evaporative losses actually creates microclimates in the area where they're constructed, based on the amount of moisture and water going into the atmosphere in that area. So thank you for listening, and I hope to have a good discussion this week based on cooling towers and energy production. Thank you.